Alright, let's try and run through this with the washing machine running in the background. Alright, we're going to use the drive motor. It's going to be brought up with the variac. Input is coming in from mains, white cable, black cord. Comes into this DP-DT relay, which has, on the normally powered size, when it closes the relay for the dual pole, dual throw, it also powers this transformer, which powers the coil, which shorts it and puts the 120 volts from mains through to the other side, which comes out, goes into here. This comes around, goes back up into the variac. Variac comes out and goes through this inverter box, which I emptied out, which is nothing but a socket. It comes out and goes back into the bridge rectifier. So, I mean, this is a lot like the relay out of the bridge rectifier, or sorry, a lot like the keg, QEG. This comes out and then goes directly into the DC motor through an ammeter, so you can see what the ammeter reading is. So we'll go ahead and power it and spin it up, and we'll show you what the VARs come up to be, as well as the input amps. I've added, it was initially 10 UF for exciting capacity with an additional up to an additional 5 UF for a total of 15 UF capacity for the exciting capacity on the alternator. I've added another pair of 10 capacitors, 10 UF capacitors in series with already 20 UF capacitors in series, because I need the higher volt rating, because I'm getting up into 500 volts, which is more than a single capacitor is rated for. And then I additionally have the 5 UF cap bank still attached, which you know, those are good to 660 VAC in that bank. So right now it's set for 15. Sorry, it's set for 17. There's also the 2 UF is on in the cap bank back there. But we'll go ahead and spool this up now. So we'll flip this on so that it shuts the relay. And then we'll spool up the variac over here. Let's see. Get an angle without blocking the light on the ammeter. Alright, so here we go. Shoot to keep it at about 5 amps. We'll spin it up. The variac is constantly being turned all the way up to the max target position. Turn up the variac the last little ways right here. This is going to bump the volts and the bars up a little bit, so I'm going to show you over here. And that's just going from right here to right there. The green mark to the black mark. The input amp. can hear the RPM sag as the motor's doing more work. Getting up there. Let's see. Go ahead and push it a little further here. Throw another 1 UF. Actually, that's the last 1 UF. I got one more UF to put on. Sounds like it's doing some work there. We're at about 7 amps, bars, 551 volts. Input still at the 110 VDC. Amp draw is about the same. About 7.5 on the thumb. Check the RPM. RPM on. Let's do some work. 2400. So, what's happening? Let's shut this off. So normally flipping that switch, this switch, would take the output from the alternator and feed the AC back in here, and it would just go through and get converted in and feed the DC motor again. But we aren't quite there yet. We still have to do the gapped exciter and see what happens at that point. But you can see with the full 20 UF in there, the RPM was significantly dropped. So at you know, let's see, what is it, 15 UF? 16, 17 UF. So at 17 UF, RPM is about a little over 3,000 RPM. And the ideal target RPM, which is where you want to have this thing spun at, is at the 3,600 RPM mark, right? That's where the target is for the alternator, for the exciting capacity. So it may be that what's needed is to overspool the alternator initially, meaning get a smaller pulley on this side of the alternator so that it spins much faster, bring it up to the resonant point, but then as we load it down, the resonant point would be reached because of the smaller pulley at a lower RPM on this side. This would reach the 3,600 RPM sooner, and so we'd have voltage climb to be left to play with on this side on the variac, right? We'd have some variable voltage left to be able to adjust and bring it up even higher as the RPM was being affected by adding the capacity. So I mean, that's something to look at. And then of course we still have the gapped exciter, which has to be put together and checked out. So that's it.